Hi, everybody. Today we're going to look at the t-test. We're going to work through a couple of examples on the t-test. Again, you need to do these with your calculator, okay? And calculate the p-value with your calculator. So let's take a look at how we do that. So I'm going to share a screen. This is a handout that's attached to your news item in D2L. Okay, and so these are examples of t-tests worked out. So I have question A and question B. Okay, so in A, it says a consumer researcher claims that the mean miles driven to a grocery store in the US is at most 9.3 miles. So notice at most means that amount or less. Okay, if it was at least, it'd be that amount or more. Okay, you decide to test this claim. You randomly select 43 grocery shoppers and find that the sample mean is 9.58 miles and the standard deviation is 7.5 miles. Now I want you to note how it says the standard deviation. It doesn't say the population standard deviation. If it said the population standard deviation, you would use a z-test. But since it just says the standard deviation, you should use the t-test. If you're not sure if it's a population standard deviation, or if it clearly says it's a sample standard deviation, then you have to use the t-test. The only time you use the z-test is if it absolutely positively says the standard deviation of the population is. Okay, so let's take a look at our H0 and HA, our null hypothesis. At most, that amount or equal, equal to that amount or less, that would be our null hypothesis because it has equal in it. So the mean is less than or equal to 9.3 miles. That's also the claim. HA then would be the exact opposite. It's greater than 9.3 miles. Our level of significance is 0.05. Since it does not specifically give us a population standard deviation, we should use a t-test. Remember, the test statistic for the t-test is basically the same as with the z-test, except there's a significant difference. It uses a sample standard deviation here. That's where the S comes in, rather than that sigma, which is the population. So that does change things a little bit. It also uses a degree of freedom. The degree of freedom for the t-distribution using this test would be the sample size -1 or 42. We generate a p-value of 0.0093 with the calculator again, and we'll look at that input and output in a minute. Now 0.0093, that's less than the level of significance, so we're going to reject H0. So if we reject H0 and H0 was the claim, that means we cannot support that claim. Okay? So again, I'll reiterate that here in 6. Since the claim is H0 and we rejected H0, we can't support the claim. So this means that we cannot support the claim that the mean number of miles driven to the grocery store is at most 9.3 miles. Let's take a look at the output and input. So to get the input and output, whoops, that's a little too far. Let me scroll up here a little bit. Get the input and output. So we go to our stat key, we scroll or we arrow over to tests, and we choose number 2, the t-test. Since the mean and standard deviation are calculated for us, we're going to use stats. We'll take a look at some examples a little bit later on when we use data, but for now we're using stats. Mu0 is the mean in the hypothesis, the null hypothesis. So that's 9.3. X bar is the sample mean. That's 9.58. The standard deviation is 0.75. That's given to us as a sample standard deviation. So note the S, there's a change from the z-test where it had sigma. This is the sample standard deviation. Our sample size is n equal 43. We highlight the symbol in the alternative hypothesis, and we go down to calculate. When we calculate, we get this input down right here, 9.3. Mu is greater than 9.3. That's the alternative hypothesis. We get a t-score of 2.448. We'll round that 2 decimal places to 2.45. We get a p-value of 0.0093. Again, rounding 4 decimal places. And it just reiterates X bar, not the sample size for us. Okay. And so that's where those values come from. So somebody asked me, oh, what's the p-value for this test? That's how I would generate it. I would just run the whole test and then generate the p-value. Okay. And B, an efficiency expert claims that the mean wait time for a customer service call in center is less than 3 minutes. To test this claim, you randomly select 25 calls and find the mean wait time is 2.9 minutes with a standard deviation of 1.4 minutes. At a significance level of 0.01, can you support the efficiency expert's claim? Okay. So the efficiency expert claims that the mean wait time at the call center for a customer is less than 3 minutes. So that's HA, because less than contains no equal. H0 would be greater than or equal, would be the opposite of that. Our level of significance is 0.01. And again, we're going to use a t-test because it's just a standard deviation. It doesn't say anything about it being a population. So we cannot assume it's a population standard deviation. Okay. So using the t-test, x bar is 2.9. The hypothesized mean is 3. That's a number from the alternate, or the null hypothesis rather. Our standard deviation is 1.4. Don't know why I put the 0 there. Let me delete that 0. There we go. And the square root of 25 would be the square root of n. That gives us minus 0.36 with 25 minus 1 degrees of freedom. Our p-value is 0.3621. 0.3621 is greater than 0.01. So we failed to reject A0. So now, since HA was the claim and we failed to reject A0, that means we cannot support the claim in HA. So that means we can't support the efficiency expert's claim that the wait times at the call center is less than 3 minutes. Let's look at the input and output. The input and output. The input, again, we go to stat, arrow over to tests, select number 2. And since the mean and standard deviation are calculated for us, we're going to continue to highlight stats. Mu0, the hypothesized mean, is 3. 2.9 is our sample mean. 1.4 was our sample standard deviation. 20 and 25 was our sample size. We highlight the less than symbol because that's the symbol in our alternative hypothesis. We press enter, and we get this for the output. We get the mean is less than 3. Our t-score is minus 3.0357, so on and so forth. So we'll round that 2 decimal places to 0.036 negative. And then our p-value is 0.36205, so on and so forth. We'll round that 4 decimal places to 0.3621. And that's how we got the t-score, the test statistic, up here in B. And that's how we got the p-value. Hopefully this helps. Have a good day.